Hello everyone, in this video we are going to show you how to improve our service and also how to deploy it into Docker. So what we want to do is to deploy it in a cluster using Docker Swarm. And basically we are going to explain how Docker Swarm works and how we can deploy each service. So what we did the last time is that we created two projects. One project is called Birdie server. It is a REST server. It calls the contact microservice. And the contact microservice, it's a gRPC microservice. And this microservice uses a contact message stub. That is something we need to communicate with the microservice itself. This is what you can look at the previous video for more details about that. The services are very, very simple. It from a query that returns simple text. So a REST query, it returns a simple text. So we are going to improve a bit because the last time we coded something in order to display the location of the microservice in a guest host command. But after a bit of search, I realized that get host running when the service will be running in Docker, get host will not return anything. So it won't help us to identify the instance of the service. So we are going to change that to return an ID, a UUID actually, and a counter to know the number of hits and the number of calls on this specific instance of microservice. So that will be our first change today, and then after that we do the same for the contact microservice, and then we will build the Docker image and we'll deploy it as a cluster with multiple instances, and that will be the interesting part. So we want a unique UID. And for this instance, so it's going to be a static and final information. instead of this get ID and it's so now let's do the change for this application also. So that's the test part. As I explained in a last video, the service itself as the quality of coding is not important for now. We just do that for demo. And a POC of how to use a microservice in Docker. So because we changed the behavior of the program, now we have a test failing, and it makes sense. Because instead of hello John Doe, we have hello John Doe, and now we have the UUID here. So we have to change the test. Let's say image starts with something like that. Okay. Exclamation mark. So it passed. Okay, so we have this built, and the Birdie server. Okay, so let's test our program again in a classical mode. This is the right one to run. So this application runs on port 6565. And this service run on a 20,010. So it has a URL somewhere. Okay, so if we have a localhost, yes, localhost. Actually the same this one, but with a localhost. Here we go. So we have first the UID of the gRPC server and the UID of the REST, the Birdie server, the REST server, so REST microservice. And this is our first hit, and we can, okay, so we have this constant and the number of hits that changes. Okay, great. So because when we will call the microservice, the the contact microservice from in our Docker, the host name won't be host, obviously. Won't be the same host, won't be localhost. It will be the name of one of our Docker engine virtual machine. So I'll explain that later, but for now we have to just keep in mind that we have to change something into the microservice here to be able to communicate. So in this class, we defined the host name and the port for the microservice we want to call. So today is localhost, but it will be something different. So we are going to use a property in a Spring Boot file to define the host and the port that we want to use instead of these two values. So let's do this. Oh, I just realized that I didn't put my video here. Okay, it builds. So let's run it again, and it should then change the behavior. Okay, we have another instance. So now we are going to create, sorry, we are going to create the image, the Docker image, in order to deploy into Docker. And as I said, we cannot do this because for now we cannot pass any parameters in our program. We have to define first the value of the host we want to reach, and for now we need to know the names of our virtual machine. So I'm gonna introduce you how we are going to organize our Docker stuff. But just to tell you that the host name is something very important in the architecture, and this will be resolved later by our service mesh. And so this is something very temporary that we do here. because we shouldn't predefine any host name, and yeah, we shouldn't assume any name where the service is located, even if in our case it will be enough to test the Docker Swarm. But in the next session, when we talk about the in this case, yes. Later we will discuss about this hostname subject in when we talk about console and product like that. So for now, we are going to change the hostname by containers 00, and we are going to build the project again. Because we have 3 virtual machines here, that they are called container 00, containers 01, and container 02 here. And that will be our Docker cluster. And we need to use one of those host names to call our service deployed in Docker. So let's do this. And the generated jars here will be used to build our Docker image. So let's do it, and it will be clearer once we have done that. So in order to build that, we are going to do that on a server, on a container 0, for example. And okay, so on a container 0, I usually create a Docker build, something like, let's start with, for example, the Birdie server. We will do both at the same time, so it's not really important. So let's say Birdie. And we have to create a Docker file. And I have a template that I use for any Java. So when you want to create an image, a Docker image, you have to tell Docker from what image you want to create it. So for us, it will be from an image called OpenJDK 11. And then we are going to copy the service. But the service name is a bit different here. The copy you do, it's something like, you can call it anything you want. But here, it must be the actual jar. So the actual jar will be something like what we have here. So he's gonna take the Birdie server snapshot jar and you copy it to the app jar, and the second folder is it's supposed to be the image itself. And this is a local file that we are going to grab from here. And here, obviously, it's something that we want to start. And it's going to be app_char, because this is a command line that we need to start our service for now. Okay, so here we are almost ready to build, but not totally ready. Whoa. So what we need now is a jar itself. So we are going to copy the jar. Here we go. So because we have the same name here, the build process will take this jar and it will create the image in Docker. So Docker is something that is already installed on this machine, and we have basic commands that I will not explain in details during this process, but it's not very complicated. So we have a command to create an image, but first we can just look at the list of images. Everything starts with Docker. And when you run image, you see the image. So an image is basically like a virtual machine, if you want to have a picture in your mind. So today we already have that, but don't really pay attention to what is already existing here. And we have a command to build. And it's Docker build, and the -t, and the name the image we want to build, and you have to be in a say yeah, you have to indicate the folder from where you want to build the image. So let's do it. Docker build and and we have to build an image. It's called Birdie. We have to put the version and we have to put the folder. The folder is currently the folder where we are. Okay, and from now we have a new image. Here we go. We have the Birdie image in version 1. And with the size, it's not small for two reasons. Because we took we built our image from an existing image called OpenJDK 11. And it's already in a Linux image. But you can optimize that. So you can process from another JDK and possibly another Linux image. And the result could be smaller than this. But it's not the point today. Today is to do something quite simple to illustrate how we can make it run. So we have the Birdie image ready, but it won't do anything until it can communicate with the contact service. Okay, so we are going to do the same. Let's clone the build Birdie into the Docker build contact. Then you won't have to repeat everything. So let's take the name of the service here. It doesn't matter if we still use app because it's something internal. Okay, we have that. Okay. Sign the previous command because it could be the same except this part. Here we are. And okay, it's the same name. Okay, it should work. Now we can build the way we did before. But we build the contact service here. Here we go. So Docker images. We have this. Okay. So now we can test it, but not in a swarm mode. We can test it in a single instance mode. Let's do that. In order to do this, we are going to run in a detach. I will explain Docker run. Yes, that's minus D and the port, and we have to export the port. So 6565. And yes, and the image you want to, and the image you want to, so D is for detach, P is for port, and then the image you want to run. So the port is basically, let's export the port, link the port from the Docker image to the virtual machine port. So you do not have to have any process using this port on your virtual machine. Then you have an idea key, yes. You have an ID key, yes, that shows here. And we can do the same for and 30 field. Okay, and when you do Docker PS, okay, you see that, okay, I can enlarge a bit, clear. Okay, you have your two services, Birdie and Contact, running. So now it should be available. So if we do the same query as before, and we change that, but now the host is containers 0. Okay. It replies. So it means that it definitely works in a Docker. So you see it's the same instance every time because it's the same number here, obviously. But it's not exactly what we want to do. So we want to run it in a swarm mode, I mean in a cluster mode. So it's not difficult, but there are, let's say, a list of concepts and a list of tricky settings to do, and especially to configure the swarm mode. So for now, let's say just stop our service and so because we didn't give a name, so I'll show you later. So I can use that to stop it. I'm going to stop this. Okay, then I'm going to remove them. So now, even when you do PS and when we do PS minus or, you only have so your services are not listed. I just was wondering what this was, but I can just remove it because I don't even remember what it was. So it's already stopped. So you see the status of your process here. It's actually running, and when it's not totally running, it could be in different status. It could be halted, it could be in error, but you have to stop them first before you can remove them totally. If you don't do that, your port is still busy. The port is still busy. In a swarm mode, it's kind of different. First, you have to see your list of nodes. And you see here that we have 3 containers, 3 virtual machines running Docker, and the star one is the master. We can have many masters, but for the demo, I will use only one. But in production, you need many masters. And you also need something that it's a bit of shame to be able to be forced to do that, because we need what they call registry. It's like a repository for the image, the Docker image. If you don't have that, Docker won't be able to deploy your image on every node of the cluster. And that's something to me, it doesn't make any sense, but that's the way it works, so I won't argue with that. This is why I installed a Nexus. Nexus is running here. And here it is. Because it's running on a specific port that it's not very interesting for now to know the port where it's actually running. I was able to create a repository for Docker in Nexus. It's not the purpose of this video to explain how I install it and how to configure it, because it could be quite complicated, or let's say tricky. So for now, I just want to demonstrate how the service can be deployed and how it runs. But in a separate video, I'll explain the detail of how to set up everything. So just keep in mind that my Nexus service is a container that runs on a virtual machine container 0. And to reach this application, I'll go through a gateway, Nginx gateway, which is actually another virtual machine that I have here, that is running here. That's my Nginx machine. And it's totally out of scope to explain everything, but the Nginx basically redirects all the traffic for the Nexus, especially the HTTPS traffic, because this is where the trickiness starts, because Docker Swarm need to be HTTPS to grab the images from the registry. But once it's configured, when it's set up, you are able to push and pull images into this registry. So it's what I'm going to show you now. Okay, so first we have to tag the image. That's another weird thing in Docker, but when you have your images, okay, you have first to give your image here another name, and this name must be your repository name slash and your image name. So let's do that. Let's do another tag, docker tag, and you have to select your birdie v1, and you give another tag name, and nginx to, that's my registry, and the port I set up, it's 103. But again, everything will be explained, why is this port and everything, in another video where I can explain how to set up the registry. Just keep in mind that's your registry location. And I put the same name, birdie v1, and I tag it. So docker images. And then now I have a new tag on the image that is called, that has a bigger name. Let's do the same for contact. Okay, now we have to push those image into the, that's quite simple. I'm not sure I have to be logged on before, but let's try it without login. And let's see what's going on. And push, let's try this one first, so contact one. Yeah, it works. I don't have to log on first. We don't have to log on because it's already set up somewhere, and it's part of the tricky configuration of everything. So this way we push the image of the contact service into the registry, and this is why the other node will be able to deploy, automatically deploy a service that they don't know. And let's do the same for birdie. Okay. So now I should be able to start a service, those service in a swarm mode. So to do that, we have the Docker service. It's kind of the sub command. Docker is a list of commands, and Docker service is another list of commands that we, no service running for now. But it's interesting. So let's start the contact first. And so to do that, I think it's something like a create, and we have the port and the replicate. So yeah, something like that. Okay, look, service, create 65, because it's the same as before. We have to open the port and replica. So let's say 2 replicas for now, and we have to put a name. So let's say contact, and then I think the image, yes, nginx 2 slash, no, let's say, so we have to put full name, contact. It's kind of very long, definitely. So that's the contact, and the name contact, and a replica 2. So replica 2 means that we should have 2 instances for now. Okay, so here we go. So we have the service running. So Docker service list, it runs, and if we do service ps and we put the name of the contact, we see that Docker choose container 0 in container 1 to run that. And if we do that, if we go to the other containers, let's say the one here, and you ask for Docker PS this time, not service PS, but PS, and you can see that you have an instance of the contact service running. And you see the command here. So that's interesting. And okay, we can do the same for Birdie. And this time not the same port, obviously. Replicato, Birdie, Birdie. Same thing. Birdie. Okay. Let's take a look. Okay, that's interesting. It chose 0, 1, and 2 to run them. Now, so on node 0, if I look at the list of service running, I just have the contact. I don't have the Birdie service. But this should be enough to make them run. So now I will run the same command as before. I open another tab, not to cheat, and let's try to reach it. Yes. So that's cool. It works from the container 0. But why container 0? Because it's a cluster. Why if we do that? Oh, it works. It still works. That's interesting. But if we do a container 2, yep, it works. And the funny thing is that you really have a cluster, and from any container, any virtual machine that you or Docker engine you target, it will do the load balancing from that on any instance, even if it's not on the same virtual machine. So keep in mind that that's totally managed by Docker Swarm. But what is not managed by Docker Swarm? It's a failover itself, because a failover it's more a client concern. And if something goes wrong when you query your service on this specific instance, Docker Swarm will not retry, because it doesn't know. It doesn't know if you want to retry. So if you do something with your browser or with a curl command, it's not his job to do it again. But if it happens, if the retry occurs, it should work. The retry should work because you can have one failure on one specific service, but the failure must happen at the very moment of the query arrive. Once the service is down, it won't be reused by Docker Swarm. So the probability that you get a failure is not very important. And when it's gonna retry, it's not going to use the one that failed, because this one is down, so it doesn't count for Docker Swarm. So this is a bit different, that it's a load balancing, it's not failover. So we have other tools to do that, and this is what we will do later. To compare, when you use an Nginx and you do a load balancing with Nginx, you also have a retry and a failover. So if Nginx tries to load balance on one instance on another, if it fails, it goes to the other one. But it's not the same concept. In Nginx, it's built in, but it's not the same concept. So we have other tools that we will install later on other sessions that does exactly this, that address this concept. So for now, we have many instances, and what we want to do, and that we want to scale them. So basically, is Docker service scale, and when you put the name of your service contact, and you say how many service you want. For example, let's say we want 7 instances. That's the final. It doesn't. I mean, it's not an addition of what is existing. It's a total. And when you ask service PS contact, you have this. You have a repartition of all the nodes, all the service. So let's do the same for Birdie. Here we go. So, okay, so I wrote, so let's try it quickly from a browser, but you won't make any different from what I click a bit faster. Okay. Okay, but it's more interesting to do that with a curl command. So I'll show you, I have a script that I have to copy paste here. And okay, so okay, it's infinite script. I'll show you the script itself. It's basically, I can show you this one. The script I use is this one. So it does an infinite loop to query what we want to query. So let's try it from a Linux server. Let's use this one. Doesn't matter anywhere where the curl command exists. And this is more interesting because you see that, okay, you see that the number of hits is always increasing. So it means that every instances are triggered one after another. So if I stop it, you can see that we have 7 instances, okay? So we should have 7 UID for the contact service and 7 UID for the Birdie, okay? So if you take a look, for example, let's start from the end. You have this one, 6 CEB, for example, and you have 6 CEB. So 1, 2, 3, 4, 5, 6, 7. And then you start again, 6 CEB. Okay, 6 CEB, 6 CEB. So it triggers every microservice. And from the Birdie point of view, it's quite the same. You have 06F and 06F and 06F. So you see it's quite evenly dispatched. This is why the number of hits is it's always the same for every instances. The cool thing is that now we have that, we can try something and very interesting. We make it run, and we are going to shut down one Docker engine and see what's going on. So if I just, let's shut down this one. Let's shut down the virtual machine. So you see that we can see connection refused, but this is the time that all the services are just rebalanced, because what's going on here is that if you go here and you ask for the contact, not this one, but the service itself list, you see that you still have 7 replicas, because it detects that the 6 and the 2 failed on container 1, and it dispatched them on the container 2. So it was a process of rebalancing everything. So during this time, you can have a failure when you call the service, but keep in mind that it's only at the time where when Swarm has to rebalance everything in case of failure. But if you have a failover process with another tool like Nginx or Traefik, whatever, the problem with the failover will be managed, and you will have a retry on another node instance, valid instance. And if you have, for example, a maximum of 10 retry, it's hardly possible to have a failure in the end, because you will reach a working node. But the Swarm itself is more to load balance everything on different nodes and keep a sane processing of everything. So that's quite interesting. It's very easy to do, as we see it. So now we have set up this, we can basically do what we want, because we can stop instances, we can restart instances, we can increase the number of instances. For example, I can create another virtual machine, another Docker engine. I can put it in a cluster itself, and when it's part of the cluster, it will be able to run instances of my services. So this is what I wanted to show. The difference on managing this kind of problem, load balancing, etc., from with Docker Swarm, it means that when you code your service, we don't have to think about that. You see, when we coded our service, we didn't think that we have a load balancer or we have something. We just code as if it was simple Java service. So I think this is it for today. I hope you enjoy the video, and that we will go on with more Docker and load balancing, probably failover next time. And we are going to use Traefik, because this is a product that is very, very common now in a Docker Swarm universe. Okay, so thank you for watching, and have a nice day.